Hello, welcome back. So we're in the middle of figuring out acids and bases and acid-base concepts. So we'll do a tiny bit more today. Again, today you are taking notes, and that's actually all. There's no practice questions for today. Um, I guess I could. Make some practice questions, or I could just give you all of the answers right now. I'm just going to give you all of the answers right now. Um, Although I will say that at the point that we get into this, you're going to be like, oh, I see it. Don't worry, this is not. It's an interesting day, right? Because it has to do with stuff you actually know. Um, but this is not a terribly complicated day. Um, I did realize since the last video that we totally forgot something here. Not sure how, but that's cool. We go with it. Um, uh, Bases taste like soap, um, which hopefully you've never eaten for obvious reasons. But that kind of really bitter. When we're together in class, we all make the face. You might have gotten soap in your mouth during a shower or something like that sometime, and it just has that like it's hard to explain how terrible bases taste. This is because they're dangerous and you shouldn't eat them. Um, yeah, but that awful bitter just want to get it out of your system taste. Um, Base, great. Okay, realized I forgot that for you, so added it in. If you're following along on our page, we have just concluded part one. Sorry that I added something in the middle of your page. You can put that in a margin or something. We are down here. We're going to identify the following as an acid, base, or neutral. Okay. You actually have everything that you need already from those ions that we were talking about before. So identify each as an acid, base, or neutral. I'm going to teach you something here that's not exactly true, but it's a really good starting point. And if you get to the point where this becomes not true, you'll understand why based on this description. Acids are characterized. This is true. Acids are characterized by an H plus ion. Since you know that an acid plus a base, I already gave you this magic moment, or create this reversible reaction with water, like literally water. There are some acids that don't even carry an H plus, but they're strong enough that they interact with water and rip off an H plus. So you can have something that does not start with an H plus that is still an acid. Don't worry too much about that. In our realm, all acids will start with H. We'll do some practice questions, but all acids will start with H. Similarly, in our context especially, all bases will end with OH. Out in the real world, there are some bases that you do not see the OH as part of them, but they're strong enough that they rip apart the water and create, they take the H plus and leave the OH behind. So that's the other way that you can be a base. But for here, all acids will start with H plus, all bases will end with OH. If it does not start with H or OH, we are going to call it neutral. So if it doesn't have neither H plus nor OH, we are going to call it neutral. And I will let a future year, and I would do this even if we were all together. You do not need to be recognizing the really, really strong stuff here. Hydrochloric acid. Well, no, that's a bad example. That starts with H. Anyways, let's just roll along from here. Here's your first question. Does that start with H? Nope, starts with K. Does that end with OH? Nope, ends with BR. That is neutral. Next you've got I'm going to try to keep this kind of lined up like your page. Mostly because we'll do a little bit from the back also right here. Lithium hydroxide, does that start with H? Nope. Does it end in OH? Yep. That's base. Soon we're going to figure out how many of these groups we have. So here we have one hydroxide group. Just to point that out, there's one OH group. H2S. Here's the part that like I could assign in some work, except we could just crunch it. Does it start with H? Yes, yes it does. It starts with H. That is an acid. It's actually this easy, guys. Like the next complicating step is how many H's? There are 2 H's. Great, okay. How about this one? H3PO4. Does that start with an H? Yes, it does. It starts with an H. Must be an acid. Soon we'll say how many H's? 3 H's. Great. Next up, CaCl2, calcium chloride. Does that start with an H? No. Does it end with an OH? Nope. Right. You got this. BaOH2, barium hydroxide. Does that start with an H? Nope. Does it end with an OH? Yep. That's base. How many OHs? There are 2 OHs. 2 OH groups. Alright. Check that off our bucket list. Why shouldn't... Okay, this next question is kind of silly. Why... But it's important. Why shouldn't you... taste or touch. I was whatever. Taste or touch acids and bases in lab. Acids burn. Bases dissolve. Let's put some acids burn you, bases dissolves you. Same with all of your stuff. Yeah, don't have to go into crazy stories here, but this is why you do not mess with them, because they will hurt you. Cool. Industrial uses, especially of acids. The question says acids. Of acids. Basically anything synthetic in any part of your realm is probably fabricated in part from acid. So acidic type reactions. So for example, plastics, paints, rubber, like synthetic stuff, like synthetic fabrics are made with using acid as like a key step in the synthesis reaction. If you make a plastic out of like Legos, let's say, your acid is critical for breaking down the original structure. This is all synthetic, so your acid breaks whatever original natural thing you were working with down into its little tiny building blocks. From there you can like start to build them back up, basically. So anything synthetic, let's just say that. Industrial uses of acids, more or less anything synthetic needs acids to be built. We're going to leave it there for here, but look around at anything that is not, for example, a tree, probably needed acid to get to where it's at. Turn that page over. Here's where we're doing monoprotic, diprotic, or triprotic. Okay, and you recognize some prefixes here. Mono means 1, di means 2, tri means 3. Okay, that matches pretty well with what we were like previewing up here. Protic means that. So an H plus is a hydrogen atom with a plus charge. Hydrogen atoms have 1 proton and 1 electron. So if your hydrogen atom has lost its electron, all that's left over is the proton. So H plus is a proton. Feel free to challenge me on this because you're like, what? Do protons really run around by themselves? They do not. In reality, they bond with a H2O and they form H3O+. However, don't even worry about it. We're just going to look at that proton kind of in the barely existent moment before it sticks itself to water. So a monoprotic thing has 1 H plus ion. A diprotic thing has 2 H plus ions. A triprotic thing has 3 H plus ions. Soon we'll see mono, di, and tri hydroxic. So a monohydroxic thing has 1 OH group. A dihydroxic thing has 2 OH groups. A trihydroxic thing has 3 OH groups. Monohydroxic. Mono means 1, hydroxic means OH, dihydroxic. Di is 2, hydroxic is still OH. So 1 OH group, 2 OH groups, 3 OH groups. Alright, let's try this out. HNO2. Does it start with an H or end with an OH? Starts with an H. How many H's are there? Just 1. 1 H, that is monoprotic. Starts with an H, there's just one of them. 1 H, monoprotic. H3, BrO3. You'll start to notice that the everything else in this particular moment does not matter. All we care about are the H's and the OH's. So does this start with an H or end with an OH? Yep, it starts with an H. How many H's? 3 H's. 3 H's. Triprotic. Another one here. HCl also starts with an H. Starts with 1 H. That is monoprotic. And just to finish it out, H2NO2 starts with an H. It's got 2 H's. That is diprotic. If you're on your worksheet, this next section says name the following. Cross that out. We are going to do this monodi-trihydroxic thing, or protic. So we're going to do exactly the same thing we were doing with those as well. We've got a replicate copy here. We've got another HNO2, still monoprotic. KOH, now I've got some variety here. KOH does not start with an H. It does end with an OH. Has 1 OH group. Monohydroxic. And let's do... I'm going to give you one that's not on your page just to practice it. I'll show you the example. Does not start with an H. Does end in an OH. It's got 2 OH groups. This is dihydroxic. And last but not least, here's an example with 3 OH groups. You'll notice that I'm putting the parentheses around the OH groups. They are polyatomic ions. OH is a polyatomic ion. It has more than one atom in the ion. OH -1 is the full ion. So if you have multiples, so if you have 2 OH groups, put the OH in parentheses, 2 goes on the outside. If you have 3 OH groups, OH goes in the parentheses, 3 goes on the outside. 3 OH groups is trihydroxyl. That's a wrap. If you're on your page, cross that out. You do not need to know the names. And you wouldn't if we were in the same room together also. All of tomorrow we will spend here. Preview to the future. So tomorrow's going to be a little bit heavier and a little bit more dense. And this right here is the key to tomorrow. If you're making sense of this, you're gonna be totally fine. Yeah. So your homework for today: take a picture of your notes, upload the picture to Classroom, call it a wrap. See you tomorrow.